Are you able to see the screen? Good afternoon, all of you. Are you able to see the screen? Weekday test question paper dated 09/12 discussion. Yes? Yes or no? Weekday test question paper dated 09/12 discussion. First question only, it is given on the screen. Yes? Are you able to see the screen this? Yes or no? Please confirm. I will start the discussion. Gautam Venkat. Munishwar.
Yes, sir. Visible, sir.
Yeah, the first question visible, no? Two steel wires having equal volumes. Right. You can see the solution here. It is given two steel wires having equal volumes. Volumes are same, wires also same metal, steel. Their diameters are in the ratio 2:1. Diameters, let us say D1 is to D2. Diameter is equal to 2:1. Is equal to 2:1. Then ratios of radius also same, 2:1 only. Okay, it won't change. When the same force is applied on them, force is same for the two wires, then the elongation produced is in the ratio. Elongation produced in the ratio. So first we can apply Young's modulus for the wire y is equal to stress by strain, longitudinal stress by longitudinal strain. So longitudinal stress is equal to F by A, divided by strain is, let us say, elongation E by, that means increase in length delta L, that is taken as E. Okay, by L, total length. You can write F into L by capital L by A into E, where E is the elongation, that is taken as delta L. So y is equal to F into L by A into E. Now they are asking the elongation ratio. In that elongation, you can write F into L by y into A. Are you clear this equation? Elongation you can take left side, and right side you can put y. Then E is equal to F into L by y into A. Are you okay with this equation?
Yes, sir.
Then they are asking ratio of diameters and radius will be same for the two wires. First you can see here in this equation for the given conditions, two wires are same steel, so that y is same for the two wires. F for same force, you can apply F is same. Okay, equal volumes. Their volumes are same. Then you can write in terms of volume this one, F into L into area of cross section divided by y into area of cross section into area of cross section. A multiplied A divided, then it will become F into V by y into A square, area of cross section square. Now they are equal volumes, equal force applied, F same, V same, Y same because of same material. Then elongation is inversely proportional to square of the area of cross section. E proportional to 1 by A square. Then from this you can write where A is equal to area of cross section is pi r square. A is equal to area of cross section is pi r square, pi radius square. Then you can write E proportional to 1 by pi r square whole square. That is 1 also proportional to pi square r power 4. That means elongation is inversely proportional to r power 4. Then E proportional to 1 by r power 4. From this you can write E1 by E2 ratio is equal to R2 power 4 by R1 power 4. Okay. So what is the R1 is to R2? 2 by 1. R1 by R2 is equal to 2:1. Then R2 by R1 is 1 by 2. Then you can write R2 by R1 whole power 4. 1 by 2 whole power 4. So that is E1 by E2 is equal to 1 by 1 power 4 by 2 power 4 is 16. 1 is to 16. So E1 by E2 is equal to 1 is to 16. Option C is correct. Are you clear the solution, all of you?
Sir.
Yes.
I have a doubt in that formula, sir. Sir, E equal to FL by AY, sir. Then, sir, then you divide both by the area of cross section, sir.
Multiplied and divided.
Okay, sir. Okay, sir.
Okay. So all of you understood this? Say yes or no fastly.
Yes, sir.
Right. Next we'll go for question number 2. You can see our question number 2. Two wires of the same material. Two wires of the same material. Material is same. That means Young's modulus will be same. And length also same. Having diameters are in the ratio 2:3. Diameters are in the ratio 2:3. When they are stretched by same force. Force is same. And the ratio of energy stored in them. Ratio of energy stored in them. Okay. So we need to take two wires. Same material means Y is same. Young's modulus same. Okay. And same length L is same. Diameters d1 is to d2 is equal to 2:3. Okay. So F also same stretching force. Then ratio of the energies stored in them. Energy stored in the material we need to consider here. The ratio of the energies we should consider. Then in that case, energy stored. What is the formula you can take? There are different formulas are given. Energy stored E is equal to 1 by 2 work done. Work done by the elongation, that is F into E. 1 by 2 into F into E. Have you remember this? 1 by 2 into F into delta L or F into E. Elongation. Okay. Are you clear this? Right. Now, first let us substitute Y is equal to stress F by A by elongation by L. That is F into L by A into E. Here elongation they are not given. Okay. Stretching force is same, they are given. Then you can use E value in terms of Y. From this E elongation is equal to F into L by A into Y. F into L by A into Y. Then this E value you can substitute here. Energy E is equal to 1 by 2 F into E value. E is F into L by A into Y. Then this will become 1 by 2 F square L by A into Y. So that is E. So they said Y same, F same, okay, L same. Then this is E is inversely proportional to A. From this equation, E energy stored in the wire is inversely proportional to area of cross section. Okay, then diameters ratio they are given. That means the radius ratio also same. R1 is to R2 is equal to 2:3. So now you can see E proportional to 1 by A means that implies E proportional to 1 by pi R square. Because area A is equal to pi R square. Okay, then from this you can write E1 by E2 energy stored is equal to R2 square by R1. E1 by E2 is equal to R2 square by R1 square. So what is R1 is to R2? 2:3. R2 is to R1? 3:2. Then we can write 3 by 2 whole square. So that E1 is to E2. E1 by E2 is equal to 9 by 4. 9 by 4. 9 is to 4. So that option D. 9 is to 4 is correct. Okay. So this is the final solution for this second question. Are you clear this? Any doubt at any point? Say yes or no fastly.
Yes, sir. No doubt,
Right.
sir.
Right. So we'll go for next question number 3. A metallic wire of force constant K. A metallic wire of force constant K cut into two parts of lengths in the ratio 1:2. Then the force constant of the larger part. You can imagine there is a wire like this. Metallic wire. This wire is, let us say, length capital L. Now this is cut into two parts, and this force constant K is cut into two parts. and the ratio of length is 1:2. That means suppose this is L1, this is L2, then L1 is to L2 is equal to 1:2, and L1 plus 2 is L1 plus L2 is equal to how much? Total length L. The total length we don't know. Let us say L. Now you can relate L1 L2 also. L1 by L2 is equal to 1 by 2. From this you can write L2 is equal to 2L1. L2 is equal to 2L1. Then you can substitute L2 value in this above equation. Then L1 plus L2 is 2L1. 2L1 is equal to capital L. Then 3L1 is equal to capital L. Then what is L1 value? L by 3. Okay, then L2 value 2 times of L1. That is 2L by 3. So it is a total length if you take capital L, then the ratio of cutting is L1 is L by 3 and 2L by 3. The larger part is 2L by 3. So then what is the force constant of larger one? So first of all, what is the force constant K? How it is related? We have a relation. F is equal to minus Kx. Normally this is for spring. Okay, that means here force F. Okay, applied force or restoring force you can take directly proportional to elongation. Elongation is let us say X, or you can say E, or delta L also you can take. Okay, so in this case, a metallic wire of constant K cut into two parts, then the force constant of the larger one. So how is the force constant related to length? We need to understand here. So if you take smaller part or larger part, applied force is same. You can apply one end. Okay, then you can say constant K, force constant K into that X. You can take like a L, small l. That means some small l elongation you can imagine like that. That is equal to constant. So that means here K is inversely proportional to L. K is inversely proportional to L. Are you clear this point? Suppose this L1 length elongated, L1 part, L2 part, it has elongated some smaller values in this case. Okay. That means what if the K is high, elongation will be low. If K is low, elongation will be high. That is the point you have to understand for a given force. Okay. Then you can observe here KL is constant. So for a total length L, is K. So K proportional to, already I said K inversely proportional to elongation length. So for L by 3, you can see here L1, L by 3 part, L2 to L by 3. So proportionally, that elongation only you can expect. Okay. Suppose what is said strain, change in length to original length. That depends on the initial length, how much, and force constant. Then you can take directly K1 by K2, or you can write K value we know already. Let us say initial for Ln K value. Then you can write K by K dash is equal to, you can write like L dash by L. K by K dash is equal to L dash by L, inversely relation. No? Then suppose that L dash related to L2, because longer part, no? That is 2L by 3. Then K by K dash is equal to 2L by 3 by L. Then LL cancel, that is equal to 2 by 3. Then K by K dash is equal to 2 by 3. Then K dash is equal to 3 by 2 into K. K dash is equal to 3K by 2. So for longer part. So that's option B, 3K by 2. Are you clear this?
Yes, sir.
Next we'll go for question number 4. If the Poisson ratio of solids, yeah.
Sir, can you show that question again, sir? I can take a screenshot, sir. Okay, sir.
Question number 4. If the Poisson ratio of a solid is 2 by 3. What is 2 by 3?
Sir.
Poisson ratio. Sigma is equal to 2 by 5. What is the
Sir.
what is the Roshan?
Sir, can you show again, sir?
Okay.
Okay, sir. I took it.
If the Poisson ratio of solid is 2 by 5, sigma is 2 by 5, then the ratio of its Young's modulus to the rigidity modulus is Young's modulus is y, rigidity modulus is eta. So if you remember, you have a relation between Young's modulus and rigidity modulus. What is the relation? Anybody can say y by 2 eta is equal to 1 plus sigma. I remember this relation. Y by 2 eta is equal to 1 plus sigma. Yes or no? This relation I have given.
Yes, sir.
Then what they are asking? Ratio of Young's modulus to rigidity modulus. That is y by eta. From this, y by eta is equal to 2 into 1 plus sigma. Y by eta is equal to 2 into 1 plus sigma. So 2 into 1 plus sigma. Sigma value given 2 by 5. So 2 into 1 plus 2 by 5. That is 5 plus 2, 7 by 5. LCM 5. 5 plus 5 ones are 5. 5 plus 2, 7. So 2 into 7, 14 by 5. So y by eta is equal to 14 by 5. Are you clear this option D? 14 by 5 is a very simple question. Question number 4. Understood all of you?
Yes, sir.
Right. Next question number 5 you can see here. Question number 5. When a load on a wire is slowly increased from 3 kg weight to 5 kg weight. When a load on a wire is slowly increased from 3 kg weight to 5 kg weight, the elongation is increases from 0.61 millimeter to 1.02 millimeter. The elongation is increases from 0.61 millimeter to 1.02 millimeter. The work done during the extension of the wire is that means extension from 0.61 to 1.02. In that case, what is the work done value? So first, what is given in the load? When the load on a wire slowly increases from 3 kg weight to 5 kg. So here, load means applied force only, no? F. Here you can say mg load. Mg means 3 kg weight. 3 into 3 is the mass, kg weight. Kg weight means 3 times of g. 3 times of g. G means, let us say, approximately 10 they are given. Then 3 into 10. That is 30 newtons. That is initial force F1. Then F2 final force is equal to that 5 kg weight. 5 into 10, 50 newton. Applied force increases from 30 newtons to 50 newtons. And the elongation delta L or E increases from E1 is equal to 0.61 millimeter. And E2 final is 1.02 millimeter. 1.02 millimeter. Okay. Then what is the work done value? It's the work done during the extension of a wire from 0.61 to 1.02. So that means what is the formula work done? Direct formula in terms of force and extension. 1 by 2 into F into E. Are you clear? 1 by 2 into F into E. Then we need to consider this is the W1, the final W2. So W1 is equal to 1 by 2 into F1 into E1. W2 is 1 by 2 into F2 into E2. Okay, then it is changing from F1 to, that means E1 to E2. Okay, the difference of this work you have to calculate. Final work minus initial work. W2 minus W1. This is the work done during the extension. That is 1 by 2 into F2 into E2 minus 1 by 2 into F1 into E1. So you can substitute all the values you'll get. So that 1 by 2 into F1. F1, first F2. F2 is 50 into 1.02 mm minus 1 by 2 into 30 into 0.61 mm. So So this you can solve 1 by 2 common. 1 by 2 common. Mm is common. That means 1 by 2 into 10 power minus 3 into 50. 50 into 1.02. That means so 5 into 10.2 you can write. You can calculate 1.02 into 50. That means so 10.2 into 5. 10 you can multiply. 2 5s are 10. 1. 1 5s. So 10. 51. So this is 51 minus. So 30 into 0.61. So this you can calculate as 6.1 into 3. 3, 18. 18. This is 18.3. Okay. So 51 minus 18.3. 7. 32.7.
Sir, 32.7.
32.7. So 32.7 into 10 power of minus 3 divided by 2. So that is equal to 16.3 roughly, or 16.4 approximately, into 10 power of minus 3 joules. Difference in energy joules. Then what is the value? 0.16 or 0.016. 0.0163 joules. 0.0163 joules. So what is the value? 0.016. Option B. Option B is the 0.016. Are you clear this? Are you clear? Question number 5. Yes, sir. Right. Next question number 6 you can see here. The compressibility of water is 4 into 10 power minus 5 per unit atmospheric pressure. Compressibility C. Compressibility C is equal to 1 by K. Have you remember? Reciprocal of bulk modulus.
Yes, sir.
Compressibility C is equal to 1 by K, that is equal to 4 into 10 power of minus 5. 4 into 10 power of minus 5 per unit atmospheric pressure per 1 atmosphere per 1 atm. Then the decrease in volume is 100 centimeter, 100 per centimeter cube. Decrease in volume. 100 centimeter cube water under a pressure of 100 atmosphere. Pressure P is equal to 100 atmosphere. Okay, then the decrease in volume you have to calculate. The decrease in volume of 100 centimeter cube water. So water V is equal to 100 centimeter cube. That is centimeter cube. What is delta V? They asked. Decrease in volume. Okay. Then you have relation K bulk modulus is equal to pressure P by minus delta V by V. Okay. Volume stress by volume strain. Then what they're asking, minus delta V, decrease in volume. Minus delta V is equal to, or we can write one more step. That implies you can write V, you can write outside, K is equal to P into V, volume by minus delta V. Then I want minus delta V. Minus delta V is equal to P pressure into volume by K. P pressure. Then minus delta V, decrease in volume, is equal to P into V into 1 by K means C, compressibility. P into V by 1 by K is equal to C, compressibility. Then you can substitute. Then you can substitute. Please mute yourself now. P volume into 1 by K is C, compressibility. Then you can substitute P is pressure, 100 atmosphere. into volume 100 centimeter cube into compressibility is 4 into 10 power of minus 5 per atmosphere. Atmosphere cancel. Here first one P is 100 atmosphere, no? ATM cancel atmosphere. Then here 100 into 100 centimeter cube into 4 into 10 power of minus 5. Okay, so that answer is 4 into 10 power 100 into 100 10 power 4 into 10 power of minus 5. So 4 into 10 power of minus 1 centimeter cube. So that is equal to 0.4 centimeter cube. So option is 0.4 centimeter cube. So this is the decrease in volume. Sixth question. Decrease in volume is 0.4 centimeter cube. Are you clear this, all of you? Yes? Okay.
Yes,
Next we'll go for seventh question. The breaking stress of a material is 10 power 6 Newton per meter square. The breaking stress of a material is 10 power 6 Newton per meter square and its density is 3 into 10 power 3 kg per meter cube. The least length of the wire in which, when the suspended vertically, breaks under its own weight. Suppose you can imagine this is a wire suspended like this. You can imagine like this. This is the rod. You can, instead of wire, you can take some small rod. You can understand. So its own weight, it has a mass m. You can imagine. So its own weight, its length L. Then at the center of mass, mg is acting. Weight vertically downwards. It's mg acting like this from the center of mass at a distance of L by 2 from the fixed support. Then, due to its own weight, so it has to break. It has to break. For that, breaking stress is given. Breaking stress is equal to maximum tension allowed. BS. Breaking stress is equal to 10 power 6 Newton per meter square. This is the maximum stress that is allowed, or maximum tension also can take. And the density rho is equal to 3 into 10 power 3 kg per meter cube. Okay. Then normally what is the breaking stress formula? Breaking stress BS is equal to breaking force B force, breaking force by area of cross section. Yes or no? F by A only, no, normally breaking force by area of cross section. Okay, that is one thing. Then actually what we need to calculate? So here what is given? Breaking stress is given, density they are given. The length we have to calculate. So breaking force means what you can say, weight only, mg. So that is equal to, you can take mg by A, area of cross section. This mg how to write? M is equal to, you can take density into volume. So that is density into volume. Total volume is area of cross section into total length. So rho A L. Then you can write rho A L into G. M means rho A L into G by A. So A cancel. Then breaking stress BS is equal to rho LG. Then this length L is the maximum length that is allowed after for this breaking stress. Okay, beyond this length of the rod, then the breaking stress will overcome. Then the weight will be breaks. That means the rod will be breaks into two parts. So that L is equal to breaking stress by density into G, rho into G. What is the breaking stress value? 10 power 6. By density value 3 into 10 power 3 into G. G value let us say 10. So the 10 power 6 by 10 power 3 into 10, 10 power 4. That is 10 power 6 minus 10 power 4, 10 power 2 by 3. That is 100 by 3. 100 by 3. Then 100 by 3 means approximately 33.3. Okay. So approximately meters. So what is the answer here? 33.3 means 34 nearby, 34 meters. If it is 34 meters length wire, that means the rod or wire up for a breaking stress of 10 power 6. Then if it is 34 meters beyond even 1 inch also, 1 centimeter also, it will break.
Sir, can you
Yes.
say again that
Yes, that is the maximum length that is allowed is 33.3 meters. That means approximately they are taken 34 meters. Okay, that means the least length is 34. That means beyond that 34, if you take even small increase in small centimeter length also, it will break.
Okay, sir.
Yeah, that is the least length condition. Okay, are you clear this? Right.
Yes, sir.
Next, we'll go for 8th question. The Y of a material, Young's modulus of a material is 200 gigapascal. 200 giga means 200 into giga 10 power 9 into Pascal means Newton per meter square. So 200 into 10 power 9, that is 2 into 10 power 11 Newton per meter square. That is the Young's modulus. If the coefficient of linear expansion is 15 into 10 power minus 6 per degree Celsius. Coefficient of linear expansion means what? Alpha. Alpha is equal to 15 into 10 power of minus 6 per degree Celsius. 15 into 10 power of minus 6 per degree Celsius. This is the alpha value. Then it is fixed at two ends and is cooled by 100 degree Celsius. Okay. So now it is at certain temperature fixed at both ends like this. Suppose it is fixed at both ends. This rod is. Suppose initially at suppose your room temperature, okay, 33 degrees Celsius. Then it is cooled by 100. That means 33 degrees reduced. What happened? It is fixed at two ends and is cooled by this much. And the thermal stress produced in the rod. Thermal stress produced in the rod. Okay, that means it may be compressed because of cooling. No? If it is heating, expanded. Either compressed or expanded, both are stress only. Either it may be compressed or it may be expanded. Both cases, the stress is produced only. Okay. So in that case, we have a relation. What is that? Young's modulus is equal to, in the case of thermal stress, okay, Young's modulus Y is equal to thermal stress. Let us say T for thermal, T stress by T strain, thermal strain. Okay. Then they are asking thermal stress calculation. What is strain produced in this? So increase in length or decrease in length. Okay. We know already L2 is equal to L1 into 1 plus alpha delta T. If the delta T rise in temperature or decrease in temperature. L2 is equal to L1 into 1 plus alpha delta T. Then L2 minus L1 is equal to L1 alpha delta T. Delta T is the change in temperature. Then L2 minus L1 by L1 is equal to alpha delta T. Then L2 minus L1 means delta L by initial length L. Delta L by L is equal to alpha delta T. So what is this delta L by L strain? That's the thermal strain. So that is equal to alpha delta T. Then you can write thermal stress is equal to T stress thermal Y into thermal strain T strain. Okay, then Y into T strain means Y into T strain means how much delta L by L, that is equal to alpha delta T. Y alpha delta T. Okay. So this is the relation we know already. Thermal stress is equal to Y alpha delta T. Y is the Young's modulus, alpha is the coefficient of linear expansion, delta is the change in temperature. Then Y value 2 into 10 power 11. Alpha value 15 into 10 power minus 6 into delta T, change in temperature is 100. So here cooled or heated 100 difference. Difference is either Kelvin or degree Celsius is same. So that answer is 2 into 10 power 11. 10 power 11, this is 10 power 2, 10 power 13. Or 11 minus 6 means 5, 10 power 5, 10 power 5, 10 power 5 plus 2, 10 power 7. Okay, 11 minus 6, 5, 5 plus 2, 7. 2 into 15, 30. 30 into 10%. That is equal to 3 into 10 power 8. 3 into 10 power 8. Newton per meter square. So option B is correct. 3 into 10 power 8 meter. Newton per meter square. That is the thermal stress produced in the rod. Are you clear the solution, all of you? Okay, so this is the time almost less than 1 minute. Remaining, I will give answer key and solutions. For remaining, I'll share this answer key papers, that means the documents. So you can check, and any doubts you can discuss with me later. Okay, at this point I'll stop. So thank you and all. Have a nice day.
Thank you, sir. Sir,
Yeah.
sir, can you send